Hi there, stats students. Before you take the quiz from topic 20, a few of you had some questions, so let's start with number 15. Going back to a study trying to get people to quit smoking. Before treatments began, the subjects answered background questions, including how many cigarettes they smoked per day. And again, there were 1,818 subjects in this particular study. They smoked an average of 22 cigarettes per day, standard deviation 10.8. For Part A, now again, people had lots of questions about Part B, but let's go through Part A so we can compare here. Part A used those sample statistics to test whether or not the population mean differs from 20 cigarettes, which is one pack per day. Okay. So again, the null hypothesis here is that people who do smoke approximately 20 cigarettes per day. So mu equals 20. The alternative hypothesis, population mean number of cigarettes smoked per day, is not 20. Okay, so that's an interesting way that they um, phrase that, telling you that it's not greater than 20. They didn't say less than 20. They said the mean differs from 20. So this is just a not equal to. Yes, the sample size is large enough, but we've talked about this before. Those people were identified. We're not so sure if the subjects were randomly chosen. All right, so we got to go through and run our t-test. So 22, which was again the given mean from the study, from that sample, compared to our null hypothesis, minus 20. Then we've got to come up with the standard error. Now again, they told us standard deviation was the 10.8 and divide by square root of the sample size. That gives us a t-value there of, oh my goodness, 7.9. More than 7 standard, almost 8 standard deviations above the mean. The p-value there is amazingly, incredibly, ridiculously small. So because the p-value is so small, we would reject the null hypothesis. It doesn't matter what significance level you use. If it's 0.10 or 0.05 or zero point 0.01, this thing is 14 zeros before you get to the 4 on that one. So if this sample is representative of the general population, we have very strong statistical evidence that the population mean number of cigarettes smoked per day is not 20. Okay. So now part B, suppose that a smaller study produced the same sample mean, same standard deviation, but the sample size was only 100 people. So we go through the whole thing again. Basically, you got to change just a few numbers. So our null hypothesis, mu equals 20. Alternative hypothesis, mu is not 20. 22 minus 20, 10.8 divided by, okay, now here's where the difference comes in. It's the square root of the sample size here was only 100, which is of course 10. So we have 2 in the numerator there and 1.8 in your denominator. So that gives us a t-value of 1.85. Now again, compared to here where we had a t-value of 7.9, now the t-value is down to 1.85. So again, this is a two-sided t-test. Okay, so let's get that p-value here. Menu, statistics. We're doing a stats test. This is a t-test, so that's option number 2. No, we don't have all the data from it, so we're going to do these statistics. Now again, from our null hypothesis, that value is 20. X bar, that's our statistic from the survey. That was 22. Now, again, let's go back to what they told us here in the book. It's not overly complicated because the calculator is programmed to deal with this. The standard deviation, okay, S of x, they told us that was 10.8, and now we have a sample size of 100. Now remember, for this one is where we distinguish here between greater than, less than, or simply not equal to. So again, this is what's called a two-sided t-test because it's going to tell us the area that's greater than that t-score in the positive and less than that t-score on the negative side. Boom, there we have it. Our p-value is right here. Okay, so again, we just saw the t-value 1.85, okay, and the p-value here of 0.0670, okay. Now, if we're using alpha is 0.05, this p-value is greater than that. It's just a little bit more than that. So again, that's what the authors there are saying. We barely, but we have to fail to reject the null hypothesis because our p-value is too big. Not by much, but I mean, if that's our cutoff point, then that's our cutoff point. So for that sample, where we only had a sample size of 100, we do not have sufficient evidence to conclude the population mean number of cigarettes smokes is anything other than 20. Okay. So again, we reached completely different conclusions for part A. We rejected the null hypothesis because the sample was fairly large and we got a really small p-value, but we failed to reject the null hypothesis when the sample size was only 100. Again, bigger sample sizes, there's going to be less random variability. So the sample mean will be either more likely to happen or less likely to happen by chance alone. All right, moving on to number 18, we had some questions about type 1 and type 2 errors. And again, these are, I really wish they would have come up with something that was a better description of what's going on, but it is what it is. If you take any of these courses in college, you'll have to deal with it then too. All right, so for 18, taller taller people in business are more likely to become CEOs. Again, the null hypothesis is that the average height of male CEOs in American companies is equal to 69 inches. The alternative hypothesis is that their mean average height is greater than that. For part A, sorry, that's A. B, describe what a type 1 error would mean in this context. Okay, again, a type 1 error is when we reject the null hypothesis when we really shouldn't have. So in this case, a type 1 error would be rejecting the null hypothesis that the average height is 69, accepting the alternative hypothesis and saying, yeah, they're taller than that, when that average height really isn't greater. Okay, so again, type 1 error, we somehow make the decision to reject the null hypothesis when we shouldn't have. So the type 2 error obviously is the opposite there. We fail to reject the null hypothesis when we really should have. So a type 2 error in this case would be saying there's no evidence that CEOs are taller than this when they really are. And then there were a few questions about number 25 and how this all plays out. So survey conducted in North Carolina back in 2005 looking for a confidence interval for the mean age among fathers of newborn babies. Okay, So going with the 90% confidence interval, it's 29.49 to 30.56. A 95% confidence interval, again, higher confidence, we need a wider range of values. So that spreads out a little bit to 29.38 to 30.66. And a 99% confidence interval from 29.18 to 30.86. Okay, so again, all of that information was given to you. So for part A, based on these confidence intervals, what can you say about the p-value for a significance test of whether the population mean age among these fathers differs from 30? Again, they use that term differ. It's not greater than, it's not less than, it's just something other than, wait a minute. We take a look at this first confidence interval, and 30 is in there, and 30 is in there, and 30 is included in every single one of them. So saying that the average age of the fathers here is equal to 30 years is completely plausible in the 90%, the 95%, and the 99% confidence intervals. That's a plausible value for the population mean. So again, the way they're writing it out, because that value is in all three of the confidence intervals, then again, it's a not equal to, so this is a two-sided t-test here. The p-value for testing that has to be bigger than 0.1. Now again, really not all that clear, but it doesn't matter if we were to use the 0.05 or the 0.01 significance levels. The 30 is going to be included in each of them there. We would fail to reject the null hypothesis in every single case for every single one of those confidence intervals. Okay? Part B then, based on your answers in Part A, summarize your conclusion from that test and the p-value. Because that p-value has to be greater than zero point 0.1, we would fail to reject the null hypothesis at all the different significance levels and say that we do not have convincing evidence that the population mean age of all North Carolina fathers back in 2005 is something other than 30 years. Okay, hopefully that clarifies things. Check your email later for the quiz.